We looked at a couple examples to see how we can show two formulae to be equivalent. We did this by derivation. We are going to now study substitution rules that will help us in performing these derivations. So the first substitution rule is where we have some formula H, that's a well-formed formula. Let's say W is some proposition inside it. Now let's assume that H is a topology. So if H is a topology, then we can obtain another formula Q. The way we are going to obtain it is by replacing every occurrence of W by some other proposition R. If we do that, then what we get will also be a tautology. So let's look at an example. So a few things to remember. W is a proposition variable. That means that W is just a variable, it's not a complicated formula. Whereas this one can be a complicated formula if you like. Okay, let's look at an example. We have this formula is a tautology, which is P, and P implies Q implies Q. This is what is known as modus ponens. It is always true. You can verify it by truth table for this formula. Now, suppose we replace P by Q implies S. Now it's important we have to do it consistently everywhere. So here I have Q implies S and Q implies S implies Q implies Q. So every place where I found P, I replaced it by Q implies S. If I do that, I will get a formula Q. What we are saying is if H is a tautology, Q is also a tautology. And this is something you can verify by creating the truth table for Q and making sure that it is true in every instance. Note that this is not the proof of this substitution rule. That's something that's beyond what we are going to do in the class. This is an example of how the substitution rule works. The next substitution rule is as follows. Once again, let H be a well-formed formula. W is a proposition variable in H. Now, we are going to obtain Q from H by replacing every occurrence of W by another proposition U. What we want is this proposition U must be logically equivalent to W. If that's the case, then Q is logically equivalent to H. Now this all sounds a little weird, so let's look at an example first. So here H is a formula. Note that H in this case does not have to be a tautology, it's just some formula. We are going to take Q. Now what we are going to do is we are going to replace this by an equivalent formula. If we do that, then the formula that we get is going to be equivalent to P. In this case again, H does not have to be a tautology. The last substitution rule that we are going to have is what I'm going to call duality law, which is basically generalized De Morgan's law. So what this is saying is, let's say H is a well-formed formula. We're going to obtain Q from H by doing the following. In each instance where we have an AND, we're going to replace it with OR. We're going to replace OR with an AND. We're going to replace true with false, false with true. So this is what is called the dual of H. So let's say H is a formula. The dual would be replace every OR by AND, replace every AND by OR, replace true by false, false by true. So suppose we have a formula H that has the variables P1 through Pn as parameters, and let's say Q is the dual of it. Then the negation of H is basically obtained by Q, where you replace every P by not P. So P1 by not P1, P2 by not P2, and so on. So if you think about De Morgan's law, this is an instance of duality law, and duality law is more general in the sense that you can every time you can use De Morgan's law, you can also use duality law. So let's look at an example. So here we have not of P or Q and R. So this is basically a De Morgan's law generalization. So I'm going to replace P by not P, Q by not Q, R by not R, or by and by or. We have reached the check before you go ahead slide. So a few things I want you to have learned from this video is how do you negate a formula using the duality idea. And it involves two parts. One is changing AND to or to AND. And the other thing it involves is changing P to not P to P, as well as changing true to false and false to true. Here is one thing I want you to try out. We have a tautology P and Q implies P. Create another tautology by substituting P to P, the formula that is given on the slide. Another thing I want you to be sure about is we had an approach of truth table, but we decided that that's not going to be good enough when formulas are large. So what's the exact problem? So for example, what would happen if I had a formula with 100 variables? What would become the size of the truth table? I want you to be able to write truth table for a small enough formula, basically with a formula with less than or equal to 4 variables, and see if it's a tautology. Go ahead if you have understood this. If not, review the video, check with the TA, etc. The last part of this module, I want you to do the review quiz that is posted. Make sure that you have understood what's going on in the review quiz, and if you are not able to do it, make sure you talk to somebody from the instructional team.